Today I'll be performing an experiment to demonstrate the operation of the Ethernet network. The simulation in this lab will help you examine the performance of the Ethernet network under different scenarios. The Ethernet is a working example of the more general carrier sense multiple access with collision detect. So that is CSMA CD, local area network technology. The Ethernet is a multiple access network, meaning that a set of nodes sends and receives frames over a shared link. The carrier sense in CSMSCD means that all the nodes can distinguish between an idle and a busy link. The collision detect means that a node listens as it transmits and can therefore detect when a frame it is transmitting has interfered or collided with the frame transmitted by another node. So for this experiment, we'll be setting up an Ethernet with 30 nodes connected through a coaxial link in a bus topology. The coaxial link is operating at a data rate of 10 Mbps. You will study how the throughput of the network is affected by the network load as well as the size of the packets. So I'll be running through what we have done here. So here I have my bus and I have 30 nodes connected to it. Further, uh, my set of technologies that I'm using is the ETH Cox model list. The model set ETH Cox. I use rapid configuration to set my bus topology. Now, so when you go through doing that, so yeah, so over there you need to select things like each Cox station, then the link model as each Cox, the number of nodes, which are 30 in this case, and the tap model, which I chose as ETH tap. Then we basically just set the XY coordinates to uh, set the how does the network look on our workspace. Next, coming to the more important bit is to configure the network nodes. So I select any one of these nodes. I click on select similar nodes and then I click on edit attributes. Now over here, I I click on traffic generation parameters and I have to set these. So my start time, I'm going to set as constant, and that constant value is going to be 5 seconds. The on state time, yeah, I'm going to set it as exponential and 100 seconds. And my off state time, I wanted to keep as 0. So since Riverbed modeling doesn't take anything less than 0 or equal to 0, so I just set it to something like a 0.001 seconds of state time. Now further I have to configure the packet generation arguments. So now the interval time I'm setting as promoted. So what I did basically was this had an option of promoting inter arrival time. So what do you mean by inter-arrival time? So the inter-arrival time allows you to assign multiple values to the multiple values to the inter. So by promoting inter-arrival time, what I'm basically achieving is that I'm now able to assign various values to this attribute and hence test the network performance under different loads. Now I click OK on my. Okay, one more thing is that I'm going to set the packet size to be constant at 1024 bytes. Clicking on apply to selected objects and OK. Next, I'm going to configure the simulation. Uh, no, but okay, wait. But before that, I'm going to choose which statistics I want to see. So discrete event simulation statistics, right? So here I want to see I want to see the traffic sync. Just a minute, I'm gonna select similar nodes, choose individual DES statistics. And now I want to see the traffic sync, and I'm going to set the traffic source and packets per second. So traffic received and traffic sent. Click on OK. Next, I'm going to click on DES, choose statistics advanced, and I had already done this for two nodes. I mean, one node, that node 0. I don't know why it didn't happen for all. Uh, Select similar nodes. Choose individually statistics. Okay, so I think you have to do it individually for each and every node. So I had done it for node 0, and I've now also done it for node 9. Anyways, so let's I'll show it to you again, right? So clicking on edit attributes. Now I want to set the scalar data as enabled and the scalar type to be time average and apply to selected objects. Same, I'm going to do it for traffic source. The yeah, enabled and time average apply to selected objects. That is done. Now we can simply run our simulation by clicking on this, keeping duration to be 30 seconds. So the simulation is going to run for 30 seconds. Now clicking on run. There we have our results in the results browser. This is what we get, right? I'm going to click on stacked statistics. I'm going to click on overlaid. So here we see that. So what do we interpret from this graph? The traffic source, traffic sent in packets per second. So you can see all these peaks here. That is when the traffic was low, and okay, the traffic was low in the sense that a lot of packets were being sent per second. So we have these peaks over here, and this is when this is during the on state time, and in case of the traffic sync, traffic received, we see we have these flats and peaks. So the flats indicate that no packets were received at that time, uh, and these peaks show us that this is when the most amount of traffic occurred. A lot of packets were received per second. There was more traffic. Peaks represent that there was more traffic. Flats represent the off state time, and that is it. That finishes our experiment for CSMA.